coming back. Law of cosines. Here we go. All right, so we have law of sines. So if I gave you a problem, A, B, C, 52.17, 6, 8. All right, we got to solve something now. Well, I got A over sine of 52.17, 6 over sine B, 8 over sine C. All right, how can we solve this? We can't. We cannot solve this with law of sines because we do not have a complete ratio. All right, so we need more. Right, we need more info. We need more rules. Here's our rule. All right, law of cosines. So it's 3 different ways it can be written, but really it's the exact same thing. A squared equals B squared plus C squared minus 2 BC cos A. And then by changing the letters around, B squared equals A squared plus C squared minus 2AC cos B. C squared equals A squared plus B squared minus 2AB cos C. Alright, this is our new rule, law of cosines. So going back to our original problem. Alright, back to the original problem. Well, the only way, let me redraw it down here. Alright, so we have our triangle A, B, C, 52.17 degrees. B is 6, C is 8. The only way law of cosines can be used, alright, law of cosines, we either have to have side, 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 or side, angle, side. And a positive thing, if you use law of cosines, there's only one triangle. Right, so you can have 2 triangles with the angle, side, side setup. Law of cosines, you're either given side, 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 or side, angle, side. Alright, so here's what we got. If I want to solve for A squared equals 8 squared plus 6 squared minus 8 times 6 cos of 52.17. And there's a lot going on there, but what we really have is we just typing that in, right? We're just typing that into our calculator. 8 squared plus 6 squared minus 2 times 8 times 6 times cos of 52.17 is 41.11 blah, 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 blah. And we take the square root. A is 6.41. Done. Honestly, I think that's easier than law of sines. But, you know, both have their pros and cons. Right, so we got A now, 6.41. Now we're good to solve for angle B or angle C. So you could use law of cosines, or at the moment, jump back to law of sines. 6.41 over sine 52.17 equals, I'll go with 6 over sine B. If I do all my cross multiplying and divide, 6 times sine 52.17 over 6.41, I do the inverse of this number, and I get 47.67 degrees. Alright, so that's my angle B, which means my angle C, 180 minus 47.67 minus 52.17 gives me 80.16 degrees. Done. Alright, so there's my law of cosines. Alright, so I showed you first how to solve for a side. Solving for a side with law of cosines, pretty easy. Type it all in, hit enter, take the square root, you got your final answer. Solving for a angle, a little bit trickier. Alright, so here we go. A, B, C. A is 4, B is 5, C is 7. So I have a general rule to make us consistent as possible. If you got 3 sides, please start with the largest side first. So that means I got 7 squared equals 4 squared plus 5 squared minus 2 times 4 times 5 cos, in this case, of C. So I got 49 equals 16 plus 25 minus 40 cos C. Some common mistakes I see. Alright, so first, subtract 16, subtract 25, and we have 49 minus 16 minus 25, 8 equals negative 40 cos C. Common mistake is people combine all three of these numbers, but we can't do that. Why can't we do that? Because 40 is being multiplied to cos C. Alright, so with PEMDAS rules, we can't combine that with the 16 and 25 because it's not done being multiplied. So if we divide by negative 40, we get negative 0.2 cos C inverse negative 0.2 gives us 101.53 degrees. Now at this moment, we have the option. If we want to, we could do cosines again, or we could jump the law of sines, whatever you want. For the purpose of what we're doing, practicing this out, I'm going to solve now for angle B using this way. 5 squared equals 7 squared plus 4 squared minus 2 times 7 times 4 cos of B. 25, 49 plus 16 minus 14 minus 56 cos of B. So if I subtract 49, subtract 16, I got negative 40 equals negative 56 cos B. Alright, so then I'd have 40 over 56 cos B, and I would do the inverse of that decimal. And that gives me 44.42 degrees for angle B. And this one's angle C. Alright, so how do I get angle A? Angle A, 180 minus 100.53 minus 44.42, and I'm left with 34.05 degrees. Done. Alright, so again, the key rule we gotta remember, we can't combine these three. Alright, so if we're looking for a rule, first we subtract those, then we divide by that. And that's how we get through this. Alright, let's look at this example together. A, B, C, 51 degrees, 10, 7. Alright, so a key idea with law of cosines you have to realize is we don't have a complete ratio. If you don't have a complete ratio, you can't use law of sines. We have to use law of cosines. Alright, so I got my setup. A squared equals 10 squared plus 7 squared minus 2 times 10 times 7 cos of A. Oop, not cos of A. I know what A is. Cos of 51. And I'm going to type that entire thing into my calculator. 10 squared plus 7 squared minus 2 times 10 times 7 times cos 51 is 60.895. I take the square root of that, and I got 7.8. Done. Like I said, honestly, sometimes I feel like this problem, it's easier to just do, law of cosines versus law of sines. Type it in, enter, square root, done. Alright, so now, if I want, I could do law of cosines, or I could jump to law of sines. 7.8 over sine of 51 equals 7 over sine B. Cross multiply, divide, 7 sine 51 all over 7.8. I take that decimal answer, I type it in here, and I get angle B in this problem to be 44.22 degrees, which means angle C, 180 minus 51 minus 44.22 is 84.78 degrees. All right. I'm going to cut this video short. I don't want you sitting listening to me too long. But, you got some more practice examples, so try those out. Try the homeworks out. And again, we meet on Wednesday. We'll perfect some stuff. Friday review, and we'll get ready for the exam. Have a good